I'm going to welcome Shanika. Shanika Hope is the Director for Education and Social Impact at Google, and that's actually where my team, the Blockly team, currently sits. And she is going to be introducing Maggie, who is our VP of Education.
That's great. Hi, Rachel. Thanks so much for that introduction. Hi, everyone. As Rachel said, my name is Shanika Hope. I have the pleasure of leading a global team that's focused on this idea of universal and equitable access to computer science. This fantastic team actually sits inside of the team that Dr. Maggie Johnson leads here at Google. One of the things that we're excited about, Maggie's going to talk about the future and the state of computational thinking, which is work that we think about every day. Maggie is a trusted voice and a champion for computer science education. And as the VP of Education here at Google, she's focused constantly on this idea of internal and external technical education training and education. How do we think about it? What are the trends that are coming in? And so one of the things that we love and we get the benefit of is, as Maggie, as the leader of our organization, is she's both an educator, but also a developer at heart. And so prior to joining Google, nearly 20 years of time here with us at Google, Maggie was a teaching faculty and the director of the Education Affairs Office within the Department of Computer Science at Stanford University. She's also, just an insider piece of information, she's also a professional musician. So we are absolutely in for a real treat. Before I hand it over to Maggie, I also want to just underscore the importance of you all and the work that you do for us. The work that you do enables us to reach tens of millions of users and to expose them to computer science education every day, which is part of our core mission of driving equitable access and ensuring that no matter where you are in the world, you get access to computing education. And so thank you for all that you do to enable this access for all. And so with that, I'll turn it over to Dr. Maggie Johnson.
Thank you, Shanika. That's a very helpful introduction. And Rachel, I'm very curious about, I don't know if it was a glockenspiel or a glockenspiel, but boy, I wish I was there to play around with that. It sounds like a interesting application of Blockly. So great to see everyone in Cambridge and also, virtually. Blockly is such an important platform, not only for computer science education, but for so many other applications. And it's so great to see the community continue to thrive. So it's really great to be here, great to have all of you here. So I have a very short period of time here, so I'm going to get right to the point. What this is about is really generative AI and software engineering. Now, I'm sure you've read about or maybe even played with Copilot or Bard or ChatGPT, and you've seen the amazing capabilities of these systems to code. And it's really interesting because internally at Google, we've actually built these systems right into the IDEs that our software engineers use every day. So they have right at their fingertips code completion, code generation, debugging, and the list goes on. And what we're seeing with this capability is just an incredible boost of productivity. Our engineers are actually able to, do more quickly and to do more every day. So what does this all mean? It's really it's a very big shift. So I'm going to offer some informed speculations. They are speculations, but things that hopefully we can talk a little bit about in a few minutes. So what we're actually seeing is that the software engineering role is changing. There will be less time spent on low-level code. And what we are seeing with this productivity boost is that engineers can actually start to work at a higher level of abstraction and really think about producing more compelling, AI-enabled, sophisticated, and useful systems. So this time savings is actually translating into the ability to do more and to create more sophisticated systems. And as this role changes, as the role of the software engineer changes, so does the training and education that prepares people for that role. Now, one can imagine a future where these generative coding systems become so reliable, so capable, and so secure that the amount of time doing low-level coding really decreases for both students and for professionals. So we see a shift with students to focus more on reading and understanding and assessing generated code and less about actually writing it. Now that time saved can go towards them learning how to put those generated modules along with the ones that they write, put them together in really compelling and sophisticated systems. So this new focus on design, I think, will really start to emerge. Now, students will still need to learn computational thinking. That is a standard, being able to put these algorithmic constructs together in such a way to solve a problem. But the focus on syntax and the inner workings of programming languages, I think that will really decrease. This is where Blockly plays a really important role. What Blockly has always been able to do is to teach computational thinking in an agnostic way, which is what future engineers starting in K-12 are really going to need. So one vision of the future is you have K-12 students learning computational thinking with a block-space paradigm, something agnostic. They learn enough coding so that they can work with generated code. And then throughout the entire process, design becomes a really important theme and an emerging new skill that we're going to see that students need, that software engineers need, because that opens the door to innovation and building more sophisticated AI-enabled systems. There could even be a role for Blockly in teaching design in agnostic ways, which will be really interesting to think about as well. So that's one vision of the future where Blockly continues to play a really central role in CS education. I think a slightly more important role because as K-12 students are less focused on the actual intricacies of coding and more around the design aspects and the concepts of computational thinking, where Blockly really shines. I think it's just going to make it even more central and more critical as we see the shift, as generative AI has this impact on software engineering. So with that, I just wanted to, put something provocative out there and then see how people react and see if you have questions or comments or what your thoughts are on all of this.
Okay, I see a question in the room.
Maggie, if large language models bring up abstraction, you don't need to know all the syntax details anymore. And Blockly is doing the same. Can you also make an argument that we don't need the blocks anymore because why?
Yeah, I'm sorry, I did not. It was very soft. Could someone repeat the question for me?
Yes. Let's see. Is that mic working?
Is the mic working? I can repeat the question again.
Yeah, repeat the questions. I think it's more at my end.
Okay, if large language models, you don't have to care about the syntax anymore because it will generate all the syntax and all that stuff will just work. Blockly is also hiding quite a lot of that syntax. That's one of the nice properties. So why do I need blocks in the future if you can just have a generic text input?
Well, I think it's a really good question. What I'm looking at is the next year, 2, 5 years. I don't anticipate that this is that the need for understanding code is going to go away entirely right away, because if you look at large language models and even the fine tuning that goes on top of them to create these systems that are capable of doing more and more specific kinds of processing, specific kinds of coding, I think there will still be, at least in the near term, a need to understand, read and understand code so that you can assess the reliability, the correctness of generated code. So I think in the near term, there's still going to be a need for that. What you're talking about is further out, and further out, we don't really know whether the systems will become reliable enough such that we can entirely trust them to just do everything. That's not what we have right now. Right now, we still have a question of reliability. There still has to be a human in the loop. And as long as there needs to be a human in the loop, I think there's going to be a need to still understand the code for students and for professionals. And with that then comes this, more agnostic way of teaching computational thinking that Blockly is so good at. So I think you make a really good point. Who knows what's going to happen further down or further out into the future and how powerful these systems really will be. But currently they're not they're not reliable enough for us to just trust them that they're always going to be correct. So until we get to that place, and we may never get to that place. I mean, the great analogy that I've heard is that you look at electric cars and that last mile, that capability of it being able to do everything that a human can do, right down to every specific situation, it's not there. And we don't know whether these systems are ever going to get there as well. And as long as, if they don't get there, they are not completely reliable and trustworthy all the way to the very end there, then as long as a human's in the loop, there's going to be a need to understand the code.
So large language models will generate blocks and that you will read to see if they're correct. And
that's an interesting concept. I hadn't thought about that. That could very well be.
thanks.
Awesome. Great question, and thank you for that thorough answer, Maggie. I am going to refresh and see if there's any virtual questions. Give me a moment. All right. Any questions in the room?
Yeah, I'll go ahead and ask a question, Maggie, just because we have, different partners from different companies in the room right now. What are some of the ways that they should think about collaborating as it relates to computational thinking? What kind of conversations should they be having, and especially as it relates to Blockly, which is a platform they're all familiar with?
Gregory, I've been thinking a lot about this, because if I think about the way that in K-12 right now that computer science is taught, it's obviously it's very focused on advanced placement and computer science principles, and the approach has been sort of easing the path to undergraduate computer science and that pathway towards a career in computer science or in software engineering at the end. And that whole pathway is, I think it's going to shift and it's going to change. And I think it is all going to go up a layer of abstraction where there's less of the low-level coding, more about design. And I think that if you think about K-12 education and the current way it's taught, which is very coding specific, how that can start to change to be more computational thinking specific and even more agnostic than it currently is with Blockly. I think that's a shift we're going to see in K-12, where if at the undergraduate level, there's less of a focus on low-level coding and just less focus on coding in general, and whereas now the undergraduate program in computer science in general is very low-level coding focused. As that changes, it's going to have that impact on the earlier pathway in K-12. So thinking about what that way of teaching computational thinking, and I think it really is much more focused on that than on languages and the syntax and semantics of a programming language, how that changes as what's coming, further down the pike in the undergraduate program changes. I think that's one thing. And the other thing is thinking about whether we can start to build the instincts and the skills in K-12 students around design, because that is really, in my opinion, going to be a very much more needed skill earlier in the process and for software engineers in general, because we're already seeing this at Google, where this time savings from these tools being able to do what they do, it's allowing for features to get built more quickly, systems to get to market more quickly. All of these things are happening in such a way that it frees up the time for engineers to be able to do more. And the more is not going to be more low-level coding. It should be something at a higher level. So that's where I think where design comes in. So thinking about whether there are additional features or additional ways of thinking about computational thinking and design and how we could actually make that link earlier on in the process, I think would be a really great thing to do.